All right, trying to work on problem number 2 in the FRQs. So it gives you that there is a spring with a plate on it. This vertical plate has negligible mass. So I want to clarify that is really important when we talk about this situation, because this is not a collision between two objects with mass. It's basically a cart with mass hitting a plate that has no mass. So effectively, it's just a spring. Okay. And the spring constant for this spring is k, and it travels a distance. It starts at d, and then it's compressed some distance in this direction, right? We'll just call that x. And the cart is glued to the plate. The cart is initially held so that the spring is compressed, as shown in figure 2. And the maximum force the glue can exert is F max. So what they mean by this is that any larger than this force, and the glue will no longer hold, and the two things will separate again, right? There's no friction here. So the student plans to release the cart from rest so that it oscillates. Discuss whether it would detach from the plate during the cart's motion. If the glue is not strong enough, one student makes the following claim. If the spring is stiffer, the force exerted by the spring will be greater for the same compression, and this means that the cart could come loose as the spring expands before it reaches D. Which underlined phrase or phrases are correct? If neither phrase is correct, write none. Just realize these are not underlined. But there's only two real statements being said here. One is that if the spring is stiffer, that the force will be greater for the same compression. The other statement here is that the cart could come loose as the spring expands before it reaches D. Those are your two statements that you're analyzing here. And when you're comparing whether these are correct or incorrect, the first statement is correct. So the first statement is correct. You don't have to justify this here, you just have to explain which one is correct and which one's incorrect. So it will compress for, the force will be greater for the same compression if the spring is stiffer, right? So the stiffer the spring is, the more force is required to compress it. So it'll require a greater force, or it'll exert a greater force when it's compressed the same amount. Which ones are incorrect? The second phrase is incorrect. And that's because, it's hard to explain in the situation, but as the force is exerted in this direction on the spring, it'll only lose contact when the spring starts to pull back. And it's no longer matching the force exerting on the cart. And so, regardless of whether the spring is exerting more or less force, it'll come loose because, it won't come loose because at its max value, it'll still be compressed. It will still making contact with the cart. So by the time it reaches D here, it'll still be pushing on the cart. As soon as it passes D, then the spring starts to exert less force and slow down, but the cart can still continue at its original velocity. So the spring will slow down, but the cart won't. And so then it'll lose contact potentially, but it won't do it before it reaches the distance D. Again, you don't have to justify it, you just have to explain that it would be incorrect. For part C, or this next section here, you have this velocity versus time graph. Basically, the cart is removed, you add a very strong glue, and then the cart rolls right with positive velocity v cart. So it's the cart's coming in, like this. And it's going to hit that spring on the wall with very strong glue on it. When it hits it, it then bounces back and forth, right? So it oscillates back and forth. and it creates that velocity time graph. So we want to do, the first thing is explain how the graph can be used to, along with the mass, to figure out the impulse exerted on the cart by the spring between 4 and 6 seconds, between these time interval here. Specifically, remember impulse, J impulse, is the change in momentum. So really we need to know what the final momentum and the initial momentum is. Since the mass doesn't change, it's just a change in velocity. So really, what you're being asked to do here is to look at 4 seconds, what the velocity is, and what the velocity is at 6 seconds, and then use those two velocities to plug them in to this equation here. Basically, multiply the mass by the velocity at 6 and 4 seconds and find the difference. Which is the impulse. Part D, repeating it with a lighter cart. So the same thing that just happened with a lighter cart. It's moving with the same velocity when it collides, and then it oscillates back and forth. I'm going to explain in a paragraph how the cart's velocity as a function of time would differ from the above graph, and then to explain why each difference would occur. So, first of all, we would say that the period would be different because we know that the period is equal to 2 pi square root of m over k. If m changes is less, right, the period would decrease. We also know that the amplitude for the position would change. Remember, this is a velocity graph though, so this velocity graph wouldn't change. The reason is the max velocity for the cart would still be v cart, because that's the velocity it comes in with, right? And this is not a collision between two massive objects. Like the spring has no mass, right? So the cart comes in with v cart, right? And that's how as fast as it's going to go. Because as soon as it hits the spring, it begins to slow down, and then when it comes back and it's bouncing back and forth, it's always going to hit a maximum when it's in that equilibrium point, and that maximum is always going to be v cart. Okay, so the amplitude for velocity remains constant. Again, remember, this is not a collision between two massive objects. There's no exchange of momentum between these two objects, right? There's a change of momentum for the cart itself, but not for the cart and the spring together as like a system, okay? So the amplitude of the velocity remains the same. We can also add other information. We can talk about how the kinetic energy is less to start. So the total energy is less, right? And the distance the spring is compressed will be less as well, because there's less energy going in, or in other words, because you have less momentum when the cart gets the spring. When the spring begins to compress, it won't have to do as much work, or it won't have to have a larger impulse to stop the cart. Okay, these two things I would say are additional. The first part, you would have to definitely address in a response to this question. All right.